Is a correct screen here? Is the webcast showing that screen? Okay. Okay, so let's get started. There was a session before ours, so we don't have time to set up beforehand. Welcome everyone to join our session today, and we are going to give an introduction on how you can using Hadoop and Spark to do data analysis. I'm Wei Jiaxu. I lead the data mining and statistics group here, so I will talk about the first two sessions, focusing on how you can use Hadoop to do the analysis. Then we have another section, two sections will be led by the Dr. Ruizhu Huang, is a staff in my groups. In addition to us, we have Jason here and we have David here, and all four of us can help you guys throughout the sessions if you have any problems or questions regarding materials or how you can get to the resources there. You should already confirm with Jason about your attendance, so we can add in your account into the reservation so you can accessing them. If you haven't done that or you didn't sign up or you're not sure, you can check with Jason during our break or to send him an email during the sessions. So here's an overview about what we are going to do today. So we are breaking them into 4 sessions. The first sessions, I will give you some basic introduction on MapReduce programming model. So this is sort of the basic thing, the basic kind of computational model behind the Hadoop and also extended for the Spark. So the first hours I will spending some time to give you an introduction on what's the model about and how you can do programming using Java to using Hadoop to do your first sort of Hadoop applications. Then at the end of that sessions, I will talk about how you can get onto the Hadoop cluster with setting up attack. We have a break set for 1:50 to 2 o'clock. That is a break time, and also if you have any question regarding how you can get access to it, we are going to be here and trying to help you out on your computers. So basically for today, for the rest of sessions, we will have some demonstration and you will have chance to accessing those resources and to do some exercise. We have some demo code setting up and some demos. You will see where you can get them throughout the later today. On the second session, I will sort of like walk you through how you can working around once you're inside the Hadoop cluster, how you can run your applications and how you can compile your Java program you developed, and how you can using Hadoop in some other way other than using Java. Then the third sessions, we will again go back to some basics about Spark. Spark is something new, something better than Hadoop, but they are really different, target to different use case scenarios. In the third sessions, you will get some basic introduction on what's the meaning, on what's the difference between the Spark and what kind of thing why Spark is better for Hadoop than Hadoop for some use cases. Then after that, and we have the last sessions, and we have 1 hour assigned to it, but we expect there are only going to be like 30 minutes content, and we reserve the last 30 minutes for you to freely to explore all the exercise and we have been talking about and asking us additional questions you may have. Okay, just in general, just feel free to asking us any questions you may have during the sessions. And as you can see, we have those 3 break time that sort of reserved for those question and answer as well. Okay, so let me start with just some general like motivation things. What's a big challenge with the big data analysis? So for us, we are a supercomputing center, so we have been helping people to doing high performance computing, dealing with large type of computations for a long time before even Hadoop coming out or before even big data became such a popular word. So for the new challenge that bring by the when your data growing is really that your data analysis process just require a lot of more computational resources. The first thing is reflect is the storage, and when you're processing large-scale data and you have, say, 1 terabyte data as your input, typically your entire analysis will require at least like 3 times larger space for you to working on, like similar size of the thing for maybe your intermediate data and similar size for your output data. So that altogether, really means a lot of more data operations you need to do during your data analysis. So that's make the big data analysis harder because the data analysis, the data operation, reading data, writing data, is generally much slower than you do the computations. And also the analysis, other than that, other than the more storage means more memory usage. So a lot of time people come to us having problem to running their program because they do not have enough memory to run them within single node. So you have to spreading them out. And how you're spreading them and how you're catching them in the distributed memory is not that straightforward, not easy to do. So that's among some additional tasks. And other than those direct sort of computational related tasks, and just setting up your data may take much longer. And if you're using like a remote resources like ours, or you want to using some cloud computing infrastructure, the first thing you need to do is to put in your data into those infrastructure. So as your data growing, the network transfer doesn't really scaling up, and so you getting much longer time to getting your data into the resources and do the computation and getting out. So those are the challenge that specifically sort of being amplified by the size of the data. So to deal with this, and the MapReduce programming model is being proposed as a sort of a solution to specifically addressing those issues that raised or amplified by the challenge of the size of the data. So the MapReduce model is initially a kind of the production thing used by Google to indexing all their web archive index. And they published the paper in 2004, and it suddenly became a very popular new kind of programming paradigm and for people to use and to apply. So Hadoop is one of the first open source implementation for MapReduce models, but after that there's several other good libraries and tools and helping people to do large scale data analysis, follow the similar ideas or do some improvements on top of it. So at the core for the MapReduce programming model is really they want to dictating your programming at the two major interface. One is called map interface, and the other one is called reduce interface. The whole core ideas behind MapReduce is really, if you're from computational background, it's really not something brand new. It's really like the very old ideas we had called divide and conquer. Essentially, we want to dividing your data into smaller chunks. Then you do the processing separately. Then you want to putting things together. Then intuitively, like in the simplest way to expressing the MapReduce data is really the map is a part you want to doing things locally with your small chunks, and reduce is once you do those small local computation with a small chunk of your data, what you are going to do next to getting your final results out. So but along with these basic ideas, there are some actually very good features or ideas being implemented in the MapReduce programming model, so make it very suitable for processing the large scale of the data. The first things we are going to introduce is the first feature or most important thing is the whole idea of the MapReduce is trying to move your computation to your data. So if you recall the 2 slides back, and I mentioned one of the new challenges are being amplified by the big data analysis is it's just taking a lot longer for you to transfer your data from resources to others. And right now, I don't imagine you will store all your data on your laptop. You're going to store them somewhere in the more powerful and the bigger storage machines. In that case, in the traditional computational model, you still need to move your data from a storage resources to the computational resources. So one of the big ideas in the MapReduce is really to combine the storage resource used to store your data with the computation resources that used to processing your data. So the move computation to data is it's actually quite it's the sort of like most novel things in the MapReduce comparing to what people has been doing with the HPC before the MapReduce models. So once they are so the idea is also not just to say you should move your computation to the data, but also the MapReduce programming model also implies certain ways how your data being organized. So we are all more familiar with, say, the data being stored as individual files on your disk, on your laptop, or in a database. In the MapReduce, in the in the programming model itself, is trying to packing the data, organizing them in a more compact and more efficient way for the processing later. Some other good things with the with MapReduce is it's really trying to follow a scale out ideas to trying to scaling up your computation when you're dealing with the big data asset rather than scale up. So what's good about scale out means, like, say, if you have a certain computations that takes 7 days for you to compute on your laptops, there's two ways basically you can try to make that one faster. One is you can get a more powerful laptop, more memory, that maybe makes things a little bit faster, but that will increase your cost, and that is up to how fast the CPU can go or how powerful your laptop can be. So that type of the scaling we usually call the scaling up, because you're going to getting newer hardwares. The scale out, it means like instead of having a more powerful laptop to do that, I just want to say getting 10 other laptops and to do that. If I can run my program smart enough, then my running time may be reduced by 10-fold. So I only need less than 1 day to do that computations. So that's called scale out. So obviously scale out is much better idea than scale up if we can to do that. But also the scale up, you basically run your same program, but scale out, you definitely need to change your program for it to efficiently to run across from 1 laptop to 10 laptops. So the idea to say that MapReduce want to encourage you to use scale out is not just to say you should do that, but also the model itself has a lot of implementation and support so that your code written for 1 node can just run with 10 nodes or 100 nodes or 1,000 nodes. So you can develop your program with really small data on your laptop to testing out and to run it, and then the exactly same code, if you're doing them right, and they should be able to run over hundreds of nodes with 100 times larger of the data, then you're still getting the same performance. So that's another like really good features we really want people to learn and to use this, because it's much easier for user as you to do development and to make your program scalable. By doing those features, the good thing about MapReduce programming model is trying to hiding the system's details from the users. So you don't really need to concern how much memory, how much resources each node may have, whether they are the same or not, how you're going to do the distribution, and how you're going to scaling up from one to the others. That is part of the model also implies, and you just need to follow its interface, follow its API, then your code development could be much simpler, but the code at the same time could be more efficient and more scaling up. So that's what's a model, computational programming model about. Then the Hadoop is sort of the first and the most popular actual programming language libraries and to supporting this type of MapReduce models. It's an open source project. As I said, Google is the one who proposed the MapReduce programming models. Do you guys can guess who is the first one to do the implementation for the Hadoop? It's actually Yahoo doing the first open source implementation of the MapReduce models, and it started with a internal project inside Yahoo, then it moved to the Apache and became an open source project. So initially, the Hadoop is really just a single kind of Java jar files and to do supporting those features I mentioned in the MapReduce models. But over the times, it became much bigger and bigger. So now when we say Hadoop, it's not just mean a single jar file and you can support your run MapReduce program model, but itself is actually became more or less a system or a platform for you to do big data processing. So some key components associated with Hadoop that you have to know before you'll be able to use it efficiently is one thing is a Hadoop distributed file system called HDFS. So this is the basics on how your data going to be stored, so you can get in efficient processing. You can get when you process them, it can be run more efficiently, and it's also dictate how your data going to be distributed out in your clusters. So we will talk a little bit more on the HDFS and how you use them, and you will have chance to really just log on and to see. It's no big. It's similar to a regular Linux file system as well. The other big components we will introduce is called YARN. It stands for Yet Another Resource Managers. It's a resource managers to assign resource from a Hadoop clusters to your processings. So remember what I was saying, like MapReduce following this scale out schema led you to scaling up or increase the performance. At the same time, it's hiding the system details, so you don't really need to know what's going on in the cluster. So, but something or someone need to do that, right? So in this case, it's actually the YARN is the computational components that doing this type of resource assignment for you. So you can tell YARN for your program how much resources you needed, like in terms of the how many mapper tasks you want and how many reducer tasks you want. The YARN doesn't necessarily really follow exactly the number you're given, but it's going to do some processing based on the number you're doing, based on the current resource availabilities, and how your file being distributed out, and actually assign the resources for your program to run. So it's a big difference than if you're coming from MPI background or traditional HPC background. You can say, I want to use this number of processors, start this number of threads. You probably will get that number of those threads anyway. But in the MapReduce models in the Hadoop, that's actually not guaranteed. It's up to the resource limitations that you may have. So other than those two components that make things possible and for you to use, and then the core of the MapReduce model is a Java library called MapReduce libraries, and it has a set of Java API to help you to really programming on top of it. The MapReduce framework, and then there are some other projects with Hadoop. So one is called Mahout. It's a scalable machine learning algorithm libraries. So it has a lot of the data mining machine learning library already implemented following the MapReduce models that you can directly use with Hadoop clusters. So you don't need to reprogram or redeveloping those on your own. The Hadoop was like the core is developed in Java, so it's a native Java applications. But also the Hadoop can be used with other programming language as well. So one of the most convenient interface or the way for you to use other language to do the processing but still be able to take advantage of the Hadoop cluster is go through the what they call the Hadoop Streaming APIs. So today we will go through those 5 components about Hadoop and give you some general introduction and give you some examples how you can use each of those and for your analysis. Other than those 5, and there are a lot of other more sort of higher level application help you do like a SQL type of the queries or database type of the operations. We're not going to cover them today, but if you're interested, just feel us to email us or let us know or ask us offline so we can help you out on that as well. Okay. So any questions so far? Okay, so let's take more sort of more deeper look on how MapReduce really work inside Hadoop. So as I mentioned in the previous slides, the MapReduce framework is really as simple as you only need to define a map interface and a reduce interface. So that's a key kind of the API you need to keep in mind. Other than those two, other than the programming, 2 major programming steps, the other key concept with MapReduce is everything inside the MapReduce, the data is expressed in terms of the key value pairs. So you can think about the key as sort of some kind of ID to representing a data points. Then the value is the actual value of that data points, right? Sometimes you may be able to say just using one, and you can just using the key or just using the value without the key. We will see some examples. But internally, all the data inside MapReduce is in this sort of key value form. You don't give the key, it still has a default value associated to it. And also, the key value pairs could be any type. It could be an integer for your key, or it could be a text for your key. Or if you want to have a more complex object for your values, that's also possible. That as long as your program can correctly recognize them. So the key value pair is sort of the basic form of the data structure the MapReduce use, and then the 2 major computational steps is map and reduce. So in a simple kind of the flow chart of type of things is the processing like goes like from top to bottom. So at the top is your data. As you can see, it's a tuple with a key and the values, and then your key and the values. Those are something maybe already stored inside your Hadoop distributed file system. So when your program starts, the yarn will assign different resources, like say this number of map process to working on this set of data. The key and the value pairs, and they will be sending by group to the different map task. And then the map task will do what you're programming it to do and to getting some processing results out. So you're going from, say, K1 and V1 pair, go through the first map task. Then the map after processing, it may become to another key value pair greater than A1, B2. Then in the Hadoop system, it has a combine steps, and to combine all the key value pair from the same key together, and then it's going to do some partitions, and all the combine and the partition steps is something internally being implemented inside Hadoop. So if you're just starting with Hadoop, you don't really need to worry about them. But what that two steps does is it will you have multiple map process, and each one give a different key value pair. Some of them may have same key, and then the combined partition process is to collecting those key value pair from all the map process and putting them in the group by their keys, then prepare that key value, new key value pairs of the same keys, and send it to the reduce process at the end. So your simple processing from beginning, from one key value pair in to another key value pair out from map, and during the intermediate combined partition and shuffle and sort process, it actually became to a key followed by a list of values, and then your reducer will go into working on that key and the list of values to reduce that back to a key value pair as your final output. Okay. Any questions about these workflows? We will run through some program examples, and you will get better ideas like how the processing flow actually works. But out of those like sort of different states, it seems very complicated. But the good thing is, literally, you only need to worry about how you're going to implementing a map function and how you're going to implementing a reduce function, and all the intermediate steps, and you don't have to write on your own. You don't have to worry about those. So the example we're going to be using is called word count examples. Assuming you have learned some other language before, so I guess everyone know hello world examples when you learn any language. Is tell you how to print out. So the word count example is sort of the hello world equivalent for all the big data type of processing. And Hadoop use that, and Spark use that. The basic word count example is it's just reading a text files or one or multiple of them, and trying to counting how many of unique words are there and what's the frequency of each unique words. So the input is generally a bunch of text files, and then the output is a text file followed by here's a word, here's a frequency of the word appearance. So to implementing this inside Hadoop, as a Hadoop applications, we basically want to implementing a map task and a reduce task. So in this case, it's when you're trying to developing your own MapReduce programming applications, you don't really need to think about too much about parallelism or how you're going to distribute the work. You actually only need to think about if it is a single thread programming, how I do, and that same thing should apply. It just automatically apply to the different chunk of your data. So in this case, if we want to do in the MapReduce way, one way is we're going to from your input data, we're going to let the map to generating key value pair, right? So that's the things we use by the MapReduce. And in this case, we want to use the word itself as a key, and then the counting of the as the values. Then at the reduce part, then we want to say for each key, in this case, key is word. So for each word, we want to sum up how many counts we have from different map tasks. Then we are getting the total results. Okay, so So this logic is very easily applied to single thread. It's the same thing. It can work for your single thread thing. If you're just dividing them into 10 different tasks, it still works. So to map the actual processing to what I'll show you before with that colored diagrams, it's more like this. So your input in this case is a text file. Say this text file is very simple. It only has 9 words on there. Your input going to be splitting into different chunks. So that splitting is not something you will program in explicitly. It is something when you import your data into HDFS, it's already automatically distributed stored. So your subsequent processing going to be based on where the data it is and to do that processing. So assuming in this case we have like 9 words and the 3 words is being stored into one node and 3 words into another, 3 words into another. So we essentially have a 3 splits of your input data. Then your mapping process is going to say for each map task, it's going to be run on one node. It's going to only processing whatever the data local to that map process. And then the map process will simply generating how many words I see, and for each word I will generating I see it once, I see it once. It doesn't. Don't worry about I see it twice in the same node yet, and that part can be automatically done in the later part. So your mapping is essentially trying to dealing with the input data you have here, and say for the first one we have 3 different words, so we have 3 different key value pairs. And each one has a value 1, and similarly for other 2 nodes. You can see like once we have them, so that's what your map process need to worry about. Then for the intermediate partition, combining and the shuffling steps, your key value pair generated by your mapping process will be automatically grouped based on the different key values they have. So you have 2 cards from here, you have 1 card from this map, and then the shuffling phase will grouping those together. Then once you grouping them together, and each of those chunks can be sent to a 1 reducer and for the reduce process. So for your reduce process, you can always assuming you're getting a key and a list of values with the same key, and then you just do what you need to be done. So in this case, it's I'm getting all the word counts from my process in the reduce, so I only need to adding them up together to getting the final counts of it, right? Then you're getting your final result there. Okay, so that's sort of how the general MapReduce program processing looks like. It's very simple examples, and then it uses a lot of the built-in features of Hadoop libraries. So the things you actually need to be implementing to have those is actually much simpler. So here's a typical kind of implementation of the word count structures. You really, like if you're familiar with Java, you know like here we basically implementing 3 things. What's your mappers as a map class, and what's your reducers as your reducer class, and your main function to put in your MapReduce. It basically tells Hadoop where is my MapReduce, where is my reduce class. For the mapper class, the API has a standard mapper class APIs. So basically, your implementation should extend this mapper class, and it has a fixed signatures and its abstract class. So you need to override the map functions and to specify what the mapper does. And in the map functions, you're going to see some input like a key and value and context. Context is sort of the core of the Hadoop features. And then the key value pair in this case is essentially the input key value pair you are going to get. Right? So your processing will be just how you want to processing this particular key value pair passed to you. You don't need to worry about where you are getting them or how they are in what form. So you just need to worry about what actual computation you want to do. So in these particular cases, the input is going to be the line of from your text file. So we actually do not care the keys in that case. So the input will be some key and then the line of your input from your text file as the values. And then the subsequent processings will only worry about the values, so we don't really care about the key. So here we really just need to say we want to converting the value to strings, and we want to splitting these lines into different words individually. And for each of the words we are having split there, we're going to write a key value pair to this Hadoop context as a new key value pair as the one we are sending out, or for the subsequent processings. So for the new key value pair we are writing is in the form key and value. So in this case, the key is the actual word that appeared in the text, and the value is actually it's really just a one. It's just some more fancy version of the one here. Okay. So the actual code, except the interface you need to follow, is really just like these 3 lines of the code you need to write for your mapper class. Then is your reducer class, right? So there are some intermediate processings once your map in the work, but the other things is what the Hadoop will give you, or the library will give you. So by the time the processing result reach your reducer class, it's going to be in the form of the key and the list of values. So similarly, the Hadoop has a reducer APIs as an abstract class, and with the abstract function called reduce, you have to override and to specify what kind of the processing you want to do. So in this case, the key and the iterable values are the input for your reducer phase, and then the context is the same Hadoop context. So your processing will start with how you want to deal with this key and the list of the values. And in our cases, it's very simple, as we just want to say for all the one with the same key, we just want to sum up all the value together. And once we get this sum, we're going to write in this key and this value back to Hadoop context. Right? So again, the actual code is really just like 3 lines of the code you have to write. Then the word count mean functions is really just putting those things together. It's basically like a configurations, and you just tell, say, here's my jobs I want to run. I gave it name as word count, and then here's a class I want to using as mapper. Here's a class I want to using as a reducers, and here's what's my input class, a key class, what's my output key class, and you're setting those things up, and you can run them. Remember, like in the more complicated workflow, I said in between the map and the reduce, there are combiner, partitioner, and the reduce, and those steps. You don't have to set them. By default, the combiner will be the same thing as your reducer that being used. The difference between combiner and reducer, in a simple way, is really the same class that run locally with your map process is became the combiner. And then the reduce process runs separately with your MapReduce is the reducers, but it's the same processing being done there. And sometimes you can do it differently, and then you can have your own combiner implementation. That combiner will execute right after your map output and do that with each map task, while your reducer will be something totally different after the shuffle sort process. Okay. So any questions about these processing flows, how it runs? So really, out of those processing flows for basic Hadoop programming, you really need to implement is really just mapping and the reducing phase. And all other 3 phases is something once your data inside Hadoop, you will get like how your data being splitted, and the shuffling is a core of Hadoop implementation to do that. And then the result part is I didn't cover that in the previous program, but it automatically saved any outputs into your Hadoop distributed file system. Each reducer has a special file corresponding to. So when you run some examples, I want you to take a look, and you will see what's that for and what it means. Okay, so so here just some like recap on the details with each of the mappers and the reducers. So I highlighting them. So here's actually your input, and here is your output intermediate files. And then the mapper class is something run individually on a chunk of local data. It doesn't matter where what's the format of which node is running. All the mapper running exactly same things on the data it has access to. So the distribution of the data where the key value is giving to each map task is something done by the, so first the Yarn resource manager will assign certain resource and the data for each mapper to working on. Then the Hadoop code will automatically reading those key value pairs, those reading your input and converting and given to your map process. After the map process, the partitioner and the combiner is also a phase that running immediately after your mapper process, and locally to follow each map task. If you're dealing with more complicated processing, having a partitioner and the combiners customized could be further improving your program efficiency. But basically, the combiner is doing something reducer will do, but just in a local sense, so you have less key value pair need to be transferred out. So for example, in the word count cases, if you have two car1 from same mappers, and if you are directly pass them into the reducer phase, you need to do two network transfer for two pairs. That will take more time if you run the combiner first, where they will be rewrite out two key value pair as one as a car with value 2. Then you only need to transfer one value pairs to that. So the processing is the same as what you will be done with the reducer, but just sort of before it's being transferred out. So altogether, it will save you some network transfer time between the map task and reduce task. And then again, the reducers, the interface is has a key and then as iterable values. So this is really the things passed by the Hadoop systems to the reducer phases is by grouping those by grouping the key value pairs generated by mapper by their keys and as a more efficient data structure for your map reducers to processing. And in between them, to make those things happen, it's called the shuffle and the sort phase. This is really a phases, a implementation inside Hadoop. So if you're just started, you really don't need to look into it. But when you are getting more familiar with Hadoop and MapReduce programming, you will gradually realize if your program running very slow, it's generally because this part is running very slow, because this part need to collecting all those key value pairs, sorting them, and generating the input for your reduce phase. So each of them have their own interface that you can actually rewrite if you have a better ideas how you're going to sorting your key value pairs, and you can rewriting them and to make things running more faster. But for now, if this is the first time you heard about Hadoop, you just keep in mind have such stage there, but don't need to look further into that. Okay. So those sort of are the basic processing, what happens with MapReduce and what you need to do with when you want to do any program, follow that. And I'm using the Java as examples, but the same thing can be done in different programming language like Python or now even Scala and even R and Bash. So later in the next sessions, we will talk about Hadoop Streaming API where you can see how you can do those. So those are from programming aspect, what you need to do, what MapReduce about. And then once you have that, obviously your code won't run on its own because it depends so much on what Hadoop system support to fill all those the blank in the middle, right? So to run your Hadoop application, you sort of have to have a Hadoop clusters. I don't know like how many of you are familiar with the typical HPC sort of infrastructures. The Hadoop infrastructure is actually different than, say, a typical infrastructure for hypermesh computing for running MPI jobs. In the traditional ways, and we have all the cluster looks like something like this, like a bunch of the machines is your computational resources, and a few nodes, that's where you log into getting access to that computing resources. So that small icon is you as your laptop, and you first log into a login node. And from login node, and you maybe transfer some data into your resources. In the traditional ways, the data is stored in a dedicated storage resources, not directly in the compute nodes. Then by the time you want to run some processing, you need to tell us the resource manager of the computing clusters to say, I want to get in 4 nodes to run my program. Then you get in 4 nodes, and for each 4 nodes, you need to tell each node where you are going to get in your data from and how you're going to get in your data from. So that's sort of the typical way how a MPI program works, or how HPC being used before the MapReduce. The MapReduce infrastructure is a little bit different, because in these pictures, there is really no difference between, say, you have login nodes and all the compute nodes is exactly the same. But in the Hadoop infrastructures, and first of all, you have some login node for you to access in your Hadoop infrastructures. But within the computational resources, most of them are going to be the worker nodes or data nodes used to store your data or do the processings. But there are also a set of the service nodes that help to maintain the normal operation of your Hadoop clusters. So in a typical Hadoop infrastructures, you are still going to log into a login node. And when you're importing the data goes through name nodes that are directly stored or distributed stored among those worker nodes or data nodes inside your Hadoop clusters. And when you run the applications, and then the application is also submitted to the service nodes first, and then service nodes will decide, depends on where exactly your data stored, and to give the resources and for it to run your mapper and reducer process. So your Hadoop application, so remember when I say you may be able to say specify I want to using 1,000 mappers, but if your data is really small, it's just being stored into one node, then tell Hadoop cluster to give you 1,000 mapper doesn't really make sense, because it's only can be accessed by one node at a time. Right? So that's why when I'm saying that you can specify some, you may be able to specify the number of mapper you want to use, but it's up to the resource manager of the Hadoop really to decide how much parallelism your program actually running with. So at the tech, and we have a resource called Wrangler to supporting this Hadoop type of the infrastructures. So Wrangler is actually not a sort of static Hadoop cluster running Hadoop cluster 24/7. So it's in the running model of the Wrangler. It's more like, say, if you're interested to run this, you want to make a reservation to start a Hadoop cluster first. Say I want to start it for a week for my computations. Then we have a script to do that automatically for you. Once your reservation runnings, and you can access your Hadoop clusters inside the Wrangler clusters as a normal Hadoop clusters. Today, we're not going to talk a lot more about Wranglers, and we have a separate training sessions called Introduction to Wrangler. We gave like 2 months ago, and we're going to run that again. And if you have more questions about how you get allocation, how you get on, how you actually use them, how you make reservation, you can refer to our previous training materials for that. But typically, there's 2 steps. One is creating that Hadoop reservations, and second step is to accessing that Hadoop clusters. And for today, you really need to worry about the reservation part. We already created a reservation that's called Hadoop plus training-HPC plus some numbers. It's a little bit longer, but it's follow a specific schema. So the first one is always Hadoop plus something. And then the second part is actually your allocation name. So you assume you have any allocations on the resources on Wranglers, and when you click create reservation, it will be the middle part there. Then the last is just sort of a sequential ID we are given to all the reservations. So for today, all of you have gave us your user account, and those user account has been added to an allocation called the training-HPC. So that's where this reservation is from. So for today, you're just using that allocations, and even you have other allocations, you may want to stay with that training-HPC allocations. So that part is done. And once you're done, it's still, so the Hadoop cluster is currently running somewhere inside the Wrangler. So how you can getting access to it, so we're providing 2 basic ways you can access the Hadoop cluster. One is you can just do a command line access through the secure shell connection, and the other way is through VNC sessions. For today, it's basically the same, because we're mainly just using this command line interface anyway. But in the future, if you want to have some graphical user interface, or the Hadoop does supporting a web UI, and the Hadoop also has, there are some applications has a UI that built on top of the Hadoop, and you can start in the VNC sessions as well. This is just checking the reservations. So once you made reservations, right now the reservation is active, it's running, but sometimes when you just making the reservation, it may take some time, or you can schedule it when it's running. This is just command to checking the reservation status. From the reservation status, what you can also get in is a sort of the number of the nodes that are being used for these Hadoop clusters, and the number, the name of the name node for this Hadoop cluster, and what are the users that has access to these clusters. We do reservation per project basis, so whatever the allocation, project allocation you are in, regardless which member of your group of your project to do that reservations, that a cluster will be accessible for all the members in that project. So for the two way of the accessing the Hadoop reservations, one is VNC and one is what we call the iDive jobs. And each of them, the purpose is to assign you a node from your Hadoop cluster, so you can see your cluster, how it's doing, and run application within that clusters. You can also run, if you have your job or your Hadoop application or debugged, and it's running fine, and you can also write them as a regular Slurm job and do the batch processing to your Hadoop cluster as well. If you do now what I'm talking about Slurm job or batch processing, don't need to worry about today. We're not going to do that. We have a separate training on Slurm and how you do the batch processing, so I'm not going to go too much detail here anyway. Okay. For the VNC, for the access today, you can choose to go to the user the VNC sessions. For the VNC sessions, the easiest way is through a web interface we build. We call the waze.tech.utexas.edu. You can just open any web browser, go to that web address, and then you will have a kind of login interface. Just log in using your type credential or exceed credentials. Once you are logged in, it's actually supporting several different resources we have. Just choose Wrangler, then fill in the form. It's fairly fairly clear. So for the reservation we have it today is Hadoop plus training-HPC plus 1419, and for the queue you need to do the Hadoop. If this is the first time you're using the waze.portal, you never used VNC on Wrangler before you fill in and click Start Job, you need to actually set your VNC password that I'm going to ask you later. So once you set the password and fill in, you can start the job. It will take like a minute for it to start, and once it's running, it will run inside your browser. What you get will sort of like a remote desktop running inside your browser interface. The other ways, if you don't really need a graphical user interface and you're fairly comfortable with the command line input, you can just SSH to Wrangler, and then you can run a command called iDive. It's a stand for interactive development or something, to starting a sort of a console jobs. And what you are going to get is once you starting a jobs and you receive some job output, then you're going to be assigned to a compute node inside that reservations. So for the iDive, it's just a command, and it's taking several parameters. The one you have to give is a -r. It's specify which reservation you're going to use. Actually, if you just have one reservation associated to you, you even don't need that. You can just do iDive. It will automatically using the only one you have. But if you have more than one, you need to use -r to specify the reservation name you want to use. And also, if you have multiple allocation on the Wranglers, you also need to using -A to specify which allocation you're going to use to access reservations. The other parameters, so by default, the iDive session is 30 minutes long. So regardless what you're doing 30 minutes later, it will kick you out from that node. You can using -m to specify how much time you need. -m is in the units of minutes. So for today, I actually suggest you to do iDive with -m and giving something like 240. So you have 4 hours. So because the rest of the sessions will be you can go back to them and using them as long as you can keep them active. The default time for the VNC session is also 4 hours. And then there's no way you can really specify longer than that from the user interface. Okay, so that's right about the time for the first session. So I will leave these slides here. We will continue at 2 o'clock, where we go to more details about how you're using them, and I will walk through a lot of more details with the Hadoop clusters. But before now and to the 2 o'clock, just try to accessing the resources because we're going to really use them. Either you choose SSH to Wrangler first, then to iDive, then followed by -240, or you can go with a portal. Either way, it's fine. Okay. So yeah, if you have any problem, just let us know. We can help you. Yes. Chris. Yeah, I called you that later. I was just trying to get something from my dad since it shows open. I got a couple that showed up in like 2 hours. I didn't get some Wi-Fi. Do you tell us? Do you know what requirements there? Okay, well, with ID, that's why you can access them from now. Yeah, I'm on the main campus. So. No, that's really kind of design.
Oh, I use UTI.
Looks like you just need to. Either that or either running or search as well.
You don't have the tax count. What's your username? Or what's your place?
We didn't hide it inside this way.
Yes. So your account.
Oh, okay, so yeah, I use my UT as well.
Yes. So try the password if you can't. You can password.
Are you have you used it before? Yes.
I didn't even know that you had this. What did you need to ask?
Yeah, that's fine. What's your user ID? Thanks.
Yeah, so I added here. Yeah, so it's only 6 now. Let's try it. I'll make sure we're at everybody's. Me too.
So, here's this. We could do this. So your user account. If you cannot do iDive or you do not see the other, so if you have troubles to enter the reservation, it's likely your user account hasn't been associated with that reservation yet, right? If that's the case, let David know, and he can add you in the reservations.
Okay. Thank you.
I got somebody checking the Wi-Fi accounts. It'll just take a few more minutes.
Are you XX? So give it about 5 minutes, it'll take care of a lot of the show. Stretch your username out for me and I'll get you set up.
Okay.
Thank you.
大的那个拼命总是出错，
那就变小一点嘛。
变小，真的变小，逐渐变小。不知道为什么。我觉得 communicate node 与 node 之间的 communicate 出错，看到那个错误，不知道为啥。
Yeah, when it was added though, it wasn't active, so it didn't have.
We were talking about how to save it.
Right.
So if your user account is not in that highlight area yet, you cannot access that reservation. So if that's the case, just let David know and we will add you in. It may take 5 minutes for it actually take effective. Okay.
We had a couple people from Ireland to UTL to the Wi-Fi accounts and I called them. So they should.
So I didn't see it. Maybe stretches there, I'll double check. Yes.
So how many of you have successfully accessed to Wrangler and get a node in a Hadoop cluster? 2. So how many of you are waiting for your user account to be effective? Okay. Okay, this may take some time. So for the rest of you, if you have your user account in the reservation, do you still have problem to getting a node, or either by VNC or by secure shell connections? If you have, just let me know.
It should. I just had. It's probably gonna take a little bit for it to get through the system. Shows up. Very efficient. I don't know exactly. There. That's probably cool. It's just gonna take a little bit. There's some process of that. Kick you on the cron.
Oh, it keeps going.
The VNC password is for resources, so if you set for other like StampP or MapReduce before, you still need to set it to Wrangler.
I'm just gonna manually add them.
That's the right way, right? That's the same.
Wait, I'll take care of it.
So he can do that now.
No, I just have to pull them off and put them back on.
Okay, but can you log in to Wrangler now?
Well, once he's on the
I
project.
think we have the same case here.
Yeah, it's the thing where I was telling you about how the allocation wasn't accurate and we added it to the project.
Okay. We need to add this account as well.
Okay.
I already did this. It should be pushed out soon. No, I got you. Just I'm looking at it.
Okay.
It's the same thing if you do not, if you're not able to log in here, you can still log in there. It's up to your credential. As you set up.
So after right. So after logging, you just tap this. And you have to do the package. Just try to start. I should see the. So now not to yeah. So I need files now. I don't have the. That's fine. Just find it.
I was going to start another these guys. He's not, he's never done that. I've never seen his class. Let me try.
Okay.
So if you cannot log into Wranglers, you need to let either Jason or David know, so we can add in your credential to the Wrangler. That applies to if you do SSH, you do Wrangler, it's got tell you the password is not correct, or if you go to Wiz portal, you have user account there and you log in, but you do not see training HPC.project, and you also need to talk with Jason or David to get your user account there. Okay. So how many of you have started with WinC session or IDAP sessions on the Wrangler? Okay, a little bit more.
I think everybody I talked to gave me their name. Should be good to go except for you. They're just coming through.
Okay.
You good to go? You good?
It's still not showing up on the Viz portal. I think I just logged in through SSH.
This portal may take a little longer to refresh. I'm not exactly sure what all this information. What?
I didn't see my name on screen earlier. What's the agent?
Inside, right? I've been looking here.
What was that?
I got it here. Yeah, it's already on, so it's going on.
Okay, I'd forgotten that. I thought I had that in quick last night. A couple more.
I think we got most of your accounts sorted out, so should be able to start the sessions either through WNC or through the IDAP sessions. I'm going to continue with the second session of the slides, and if you still have trouble, don't worry. Once your account is live, and you can go back, you can download the slide and to see where they are, or you can just ask us. We can write down what reservation you can use. And also at the very end, we have plenty of time for you to do exercise later, so you can just follow along for now. So at first I want to talk about a little bit on working with Hadoop clusters, because different than your local laptop, different than the HPC system you're used to working on. If you are using the WNC session to access it, what you could do is you can actually see the cluster information through the web UI. You don't have to do that. You don't have to have the WNC session to see that. Those really just information purpose, and you can get the same thing through the command line interface if you want. But if you do have the WNC sessions opening, you can go application, start a web browser. I think we have Firefox installed there, and you can do go to the C252-101, then just column with 5070. It's a default port for the Hadoop jobs. Typically, if you're just starting out, it may be pop up already, or give you a hint about that. Again, it's not necessary. You have to do that if you're interested. I can show you later. But here, just screenshots from some previous reservation session I have. I also have a live session here that. So basically, there's two tabs you can open with the user portal. One is tell you the kind of overview of the Hadoop clusters. So in this case, we have like a 31 nodes of Hadoop clusters. So it's fairly big. So everyone should be able to get in a node and to log on to do some practices. And it gives you the overview, and it also gives you like how many distributed storage there and how many distributed storage has been used and who has been using them. That's what our information. And the other portals can give you all the application has been run on the Hadoop clusters in the past or currently running, so you can see how busy your Hadoop cluster is and what other things has been running there. You can do same thing. You can get the same information with through the command line interface as well, and the web UI it just give you some nice either way to looking at them. So regardless if you are using the VNC sessions or using the SSH sessions, if you're using VNC sessions, you can go to the system applications and open a terminals, and we're going to use go through with the command lines for the rest of the sessions. If you're starting the IDIV sessions, and you should see something, if it's successful, you should see something like this, C252- some numbers. It doesn't have to be 101, it's whatever the node being assigned to you. If you see something like this instead of login.wrangler, then that means you're successfully logged into one of the nodes inside your Hadoop clusters. So once you're inside one of the nodes, and you can run the command, it doesn't matter you are on the name node or on the worker node or on any other service node. So the Hadoop has a Hadoop distributed file systems called HDFS. The HDFS by default has a three file systems inside the HDFS called /temp, which is globally writable, and you can put in things there, and the /user, which is if you have a user account set up in the Hadoop, and then you should have a directory under /users. If you had trouble earlier with account with the reservation stuff, you probably don't have your user account setting up correctly. I can set up them for you later, or you can do the practice using the /temp for today. The var directories is something generally used by Hadoop system to writing logs, and all your job logs, system logs will be stored in there. So to access the Hadoop file systems, it is very similar to the Linux file system. It's just another kind of storage, and the Hadoop file system has what they call the file system shell. It starts with Hadoop and then space, then followed by FS. So it invokes a Java applications inside Hadoop to mimic what the Linux file system can do. So that's called the Hadoop file system shell. So once you add the Hadoop space FS, then you can give any other common, like most common Linux command you can use with the system to see the basic system structures, right? So for example, you can do listing the content of the directory. You can do Hadoop space fs, then space, then dash, then followed by ls. ls is function the same as you run ls with your normal Linux file systems. Okay. You can also do You can also create a new directory. You can also list the directories. There's a lot of the Linux command being supported through the Hadoop file shell systems. The two most important things you definitely need to use is to put in the data from a non-Hadoop file systems inside your HDFI system. So this is sort of the first things how you can get your data imported into the HDFIs for subsequent processings. So to do this, the command is put. It's followed first by the local file system on your local system. The file path to your local system. It could be one file or it could be a directory, and then followed by the path in the HDFS. You don't have to specify which one is which. It's by default if you use the first one from your local file system and the second one using to your HDFS systems. If you want to specify them for the local file system, you can add in files and semicolons and // in before your normal path. And for the HDFS, it's going to be HDFS semicolon // Then the put command is to essentially copy a file inside your HDFS from say a raster file system or where your file normally stored in the Hadoop clusters. Then once you put them in, there has a command called get to exporting the data inside HDFS to your local file system. It's just a reverse the parameters you will get. Okay. So I imagine the put and the get is something you're definitely going to use, but there are some other things you want to use. You may want to use to see the status of your particular path, or if your text file being copied into the HDFS, you can directly run cat or tail to see the output of that text file without you have to exporting them out of the file system. So that cat command is very handy. Either you want to see some output being stored inside the HDFS, or you want to see your job logs are stored inside the HDFS. Other than those, there's really a lot of other commands being implemented within this HDFS shell. If you just run Hadoop FS without any other command, you're actually going to get the help, and they will display the list of the Linux command it supports and what they do. So if you have some particular task in mind, you don't know how to do it, you can try that first to see if there is a command match to that. As I said, like the HDFI is sort of the basic core of the storage for the HDFI for the Hadoop cluster, and all the application depends on your data being distributed, stored in there to do that distributed processings. And by the way, you run the applications, you also need to essentially submitting a request to the Hadoop cluster, say, I'm going to run this job. Then that request goes to what they call the resource managers, or yarn in this case. You can submitting your job using yarn dash followed by your Java jar files or Hadoop jar file. It's the same. And the yarn will, once you do that, it's submitting your application to the Hadoop cluster for running. And if you also had the Wednesday sessions, once you run yarn to submit your job, you should be able to see in the application types. The yarn command, other than let you to submitting the application, it also can show you what are the current applications being running in the cluster or what has been doing. So you can do that by yarn and space and application. Then the parameter it takes is a dash list to list the application you have been submitted. Or you can, once you list the application, you will see something like this. Then the first very long field is actually the application ID being assigned to your application, to your job you're running there. If you sometime you may realize you made mistakes, and you can using -kill followed by that application ID to actually kill that application. So basically force it to stop. Otherwise, once your job you do Hadoop jar and putting your application submitting to yarn, if you just simply kill that job, doesn't necessarily kill the job running inside your Hadoop clusters. The other parameters is you can specify what type of application. So by default, it's only going to show all the currently running application inside the HDFS. But with if you specify you want to see all, it will also show you all the job that has been completed before or all the job that has been killed before. The other very useful command with yarn command is a yarn node that can give you the list of the node that currently healthy inside your Hadoop cluster. That would help if you had some problem with your Hadoop clusters, your job doesn't run, or your job is running very slow, maybe some node crashed, or some node has in some weird state doesn't really working. So yarn node command give you the list of the status of current node, so you can see how healthy your current Hadoop cluster is. Then the last command I want to introduce is yarn logs. This is a yarn log command that can help you to pull any application running log from Hadoop file system so you can see them. It is very handy if you need to debugging your application. Your application doesn't give you the result it desired and it has some error out. In the console, in your console, when you submit the application, the error message may not be very helpful, but there's more detailed error logs that could be found through the yarn logs. The basic usage would be yarn logs followed by dash application ID followed by the actual application ID you have run. You can get the application ID using yarn application command to see what's application ID associated to the jobs you want to debug with. Okay. So it's about Hadoop distributed file systems and how you can navigating through the Hadoop distributed file systems, and about yarn. Yarn is a basic thing to assign those resources to you. That's all on the system side and what you can do. But from your side, if you have a Java applications you want to run, this is a basic command you want to use. It's starting with the Hadoop, or it could start with yarn, then followed by jar. So it's either Hadoop and the jar and the yarn is essentially a wrapper scripts around the native Java applications. So you're still running a jar file. So you follow by the jar file. So the first three parts is similar to when you just run a normal jar file, like you do Java jar names, and followed by the class name. And in this case, instead of using Java, you need to use Hadoop or using yarn for that. Then at the end, you can give the parameter that's specifically to your application, say your input path for your work on examples, output path, that sort of things. Other than the parameters you specify with your applications, there are also a lot of sort of the parameters that you can specify with Hadoop system to governing what's a process, what's the behaviors the Hadoop cluster will use. There are literally like hundreds of those parameters, so I'm not going to. There's a lot of helpful. They have a full documents on the Apache Hadoop website. You can get in the full list of them, but there are like a handful of them. It's used very commonly. Two of those very commonly used parameters is MapReduce.map.task and or MapReduce.reduce.tasks. So this tool is specify the number of map instance you wanted to generate, or the number of reduce instance you want to generate it. You can give any numbers you want. You can give 1 million map jobs or 1 map jobs, and or you can give more 1 reduce jobs or a lot of more jobs. But your job will essentially go to the yarn. It will depend on how much splits it actually has and how many resources it has. It's generating the concurrency is more depends on it's more resource dependent rather than those parameters specified. But in general, and you want to try some larger mapper numbers and maybe not so large numbers for the reduced numbers. There's no a kind of golden rules on what numbers you should use or shouldn't use. It's really depends on your workload, how big it is, and how big your Hadoop cluster it is, and how much memory required for your map process, and how much memory required for your reduce process. You need to experiment it a little bit and to be able to finding the suitable parameters. If you just ask too many map tasks, even it's generating that many tasks, each map task will be assigned with a smaller memory pool, so your job may not be run. So things like that. So generally, you have less number of reducer because reducer may require more memory as it's getting all the mapper result and to do the processing. So you generally have less reducers than your mappers. But again, it really depends on the resources and how much resource used by your workload. Okay. So this is a basic syntax on how you're running the Hadoop command, and I gave examples on how you can run the Hadoop jar files, running the word count example code. So the word count example, what I show you is a code I wrote as an example. So we have that one there, but other than those, the Hadoop and similar with Spark, they also shipped with a example jar file. That example jar files has a lot of like pre-built example application you can run, you can test, you can just play with it. So out of that jar files, and it also has a word count. You can run that one first. So this is it's a little bit long of the entire command, but follow the same syntax. You start with the Hadoop, then jar, then it's an absolute path I'm giving there for the jar locations, and you can, if you export the jar, a class path, you may not need that entire path there. So after given the jar files and you want to specify which class you want to run, so in this case, we are running the word count class from that jar files, and then you see the -d is a MapReduce class parameters I've given to it. You can experiment a little bit, like what's the different, how different task numbers affect the actual results. In the /time/data, and I put some data. This is a path inside the HDFS. It's not in your local file systems. It's in the HDFS/time/data. In that directories, I put a list of the like example data in there. The one I'm writing there is a fairly big one. It's about 30 gigabytes. It's a Wikipedia dump from 2012. You can run that may take some time. There are also some smaller files inside that /time/data you may want to try first to see whether it's working or not. So regardless whether you're running it, by default, the Hadoop application will give you the detailed log levels and including the process on how much percentage of my price has been running and how much done at the end. It gives you some statistics on how many read and write, how long it took for your application to run. Those are the more sort of helpful informations when you first run your application to debugging, to getting the statistics about the performance. If you need to, like, if you have a very mature application, you just want to run them, you can actually turn it off so you get a nice output. For the word count examples, after you run that one, you will get your output will be stored inside the directories in the HDFS as well. So by default, it will go to your /user, your username, and then the path you're putting here. If you have trouble with your /users, your home directory inside HDFS, you can also use /temp. Basically, you can specify where you want output in. There are also some other examples other than word count in that example jar files. If you do Hadoop jar, then followed by the jar file name without any other parameters, it will print out a list of the application it's already included in that jar file. So there are some interesting ones you may want to give it a try or play with it a little bit, other than the word count. So now is begin the fun part where you can actually try them if you have get a node. If you're on the Wranglers already, we put example code and the data in this location /work number 00791 xwj. So that's actually my directory on the work. And then for that DMS Hadoop trainings, you want to first copy that directory into your home directories, so you can easily writing stuff in there or modify the code or doing things. So you just do copy. Oh, again, I forgot the -r command you need to have. Copy -r, then /work that path, then to your tilde is stand for your local home directory on your local file systems, and Hadoop. Then once you've done that, you can go to your tilde Hadoop, and that's the training code you have. Okay? So be sure to do that now, so later you don't have trouble with the permission things or trying not to do that. So inside that directory, you will see exercise.txt. So we have some group of exercises you can run. So the command I'm showing you in the slides also in there. So you can basically copy paste those commands to try it out. The same exercise.txt or a very similar version also available in a web URL. Questions?
There's a permission share copy from your directory.
So try it now. Try it again. Can you copy the directory now?
Yeah.
Okay. So once you copy, so there's an exercise.txt in there, so you can just open it to see like the first group is some just common command for you to explore the HDFS. The second group is I think running the code, and third group is how you can compile the Java code. Inside the Hadoop application, we have a word count.java code in there, so that's the code I showed in my slide as well. So you can take a look, you can modify them, you can do something else with it. The same exercise.txt is also available through the web browsers, so if that's easier for you, you can just go to this web URL and you can open it up. It's maybe easier for you to copy paste or to see them. So as you can see, it's a grouping by accessor1, accessor2, and accessor3. So let's first try to copy the thing in there, and I give you like 5 minutes or so. You can try access1 and access2. Just make sure you have access to it. You are be able to run something with a Hadoop. And if you still have trouble to log in, there's also time we can help you out. Okay. So let's just try that for like 5 or 10 minutes.
So we did have a question online. So assuming that you already have your data on Wrangler on the /data partition, what's the quickest way to get that loaded into HDFS?
You still need to do Hadoop fs/put from /data to your Hadoop cluster.
There's no way to use scoop or some other parallel way of doing that to speed it up?
We are not setting them up this way. The /data is a raster file systems. It doesn't really supporting that as well. Any other questions, or you still have trouble to access or log in?
Yes. Yeah. We were
Is it a select group, or is it's just open right now? So you can't get to these files. Yeah, or you can't copy it. Is it that you're Wait, should they be doing that from the login node, the copy? Or can they do that from the computer?
It doesn't matter. You can do it on login node or on compute node. Doesn't really matter.
Okay, sorry about that. Give it about anywhere from 5 to 10 minutes. It should update. You were able to log in though, right? Yeah. I'll keep checking it and let you know when it shows up.
That's going to be
Yeah.
your case.
Okay, there you go.
That's fine. That's fine. Just use this. So you have the down. You just need your original command to have the down and press it. You don't need the down.
Okay, so let's see. All right.
So how many of you have been able to try the at least say do Hadoop file put get something? Just raise your hand. Okay, great. How many of you still have trouble to log in? You.
I'm waiting for my name to show up.
It's coming through, Asian. I'm working on it. For all these users we just added, though, should your stuff create their user directory?
Yeah. No, it's not automatically created.
Do we have a admin account I can use to do that?
Just the su-hdfs, then you can do the create directories here.
Can you show me real quick? I can do that too. I'm sorry? Oh, okay. I'll get you one
If you do not have a home directory setting up right now on the Hadoop file systems, you can just do everything with the /time. You just specify /time and that can do the same thing. Because your account being added later, so that home directory inside HDFS is not automatically added. We can create that for you. Just another
Make your
Okay, thank you very much. That's what I did. Yeah. So this one knows. So you should have a home directory. So you should be able to make any directory.
Somebody already created a page. So maybe.
So on copy, when you copy, it's copy to the local directory. Nothing to do with webcast. And when you put, you put them into webcast. By default, it will go to if you're not manual using, so that's why it's
You can set up some process after.
it's on HDFS. We do not have a account on the HDFS, so right now I have a terabyte. So we do not have a individual code on the HDFS. Any other questions or problems?
But remember the art.
I want to take this 10 first lines and put them in a new table. And so
Right. So I think
do you have a,
So cap 2357 should be on the reservation now.
I was able to get it from Hadoop Streaming. I was able to get directly data, put it back there.
okay. So are you trying to?
So on
Oh,
the
I see. No, I think it's because you have this directory. They're not supported.
Yeah, it's not. So,
So we did more. I just created a user form. Within the new.
okay.
Slash user. Sign up.
It's trying to put in the inside.
So it did create a local data and then
Anyway, so right now
I think it's just
Is there a reply? So you really Yeah, you're just supposed to be on the second those. I guess it knows.
This one, okay, full copy.
Right. Storm is actually.
No, I told you the hard doesn't work. So
But you said this part.
Okay, so who still have trouble to log into Hadoop clusters? Can you log in now? You log in. Okay, good. Are you all got a chance to try something like just simple fs command or? Okay. I'm just going to work through the rest of the two exercises. So the first three is basic file systems, how you compile Java code, how you run the Java examples. If you just go refer the exercise, you even just do copy paste, it should work most time. There may be some stupid spelling mistake there. It should be easy to correct. The exercise 4 and exercise 5 is a more advanced test examples. So I'm just going to quickly talk over them, and then you can try to follow them step-by-step based on exercise as well. So I think exercise 4 is about Hadoop Streaming APIs. In the Hadoop Streaming APIs, remember when I say it's for that MapReduce programs, and what you really need to implement is a map and a reduce, and for the rest of them, the system can do. So the Hadoop Streaming API gives you the opportunities that you can using other programming language to do the mapper, to do the reducer, and using the standard standard output to put them in part of the Hadoop processing as well. So the Hadoop Streaming is actually it's just another jar file. So it's the same thing how you run your example jar file or run your own program. Just in this case, it's a Hadoop jar, then followed by Hadoop-streaming.jar. Then the important parameter including the input file location, output file locations. So that's where your for the work count, that's the parameter for the work count programs. And then the dash mapper specify what's your mapper implementation. And here the map could be a scripts like writing in Python or writing in Bash or writing in other language. It doesn't really matter as long as it follows MapReduce interface. It output the key value pairs into standard output. It can be used there. And the reducer again could be any implementation you want. And then the dash file map and the dash file reduce is sort of the actual script file you want to use for your map process and for your reduce process. So this is just a basic syntax of the map and the reduce in the Hadoop streamings. And you could implementing the map using the bash scripts in the example in the Hadoop trainings, and then we have several subfolders called Hadoop Streaming-Bash, Hadoop Streaming-Python, Hadoop Streaming-R. Those are just examples how we have some example code that should be working. If you're familiar with Python, you can take a look and try to do that. What I'm missing here is the Hadoop Streaming Bash examples. And all of those are really just a simple bash command, read the line, splitting the line, and then print out each word of that line as a term and one. So the term and one will be using as a key value pair in this case. That's a similar processing what you will implement in the Java program, just in the bash. And this is code for the reduce code in bash, and basically read from the standard input as a term and the numbers. And then the term and the numbers being for the same terms and the numbers being summed up together, and then it output the term and the sum the values of that as reduce. Those are really only the content in those two files. And when you're putting them together, you can specify how many map tasks you want to use, how many reduce tasks you want to use, and the input output. And in this case, the mapper, we're using a batch script and reducer another batch script. We're going to tell where the batch script is to the Hadoop structure, Hadoop clusters. Then when you run this, the file will be copied into Hadoop clusters, your scripting files, and then the system will run. Then by the time it's go to the mapper phase, instead of running your Java code, it will run that batch scripts on each node or within each map containers and to do that. The batch scripts doesn't really have a lot of the efficiency you may expect it. You can try Python version, that may be a little bit faster. But in general, the Hadoop streaming may be slower than the Java applications you do. There's some reasons caused by how it's being implemented. You can give it a try and to play with it. So one hint you can play with is, say this is word count examples, and you can specify a number of map and tasks and number of reduce. And for the Java, either you're using the word count.java file or you do example jar word count. You can do similar. You can specify the map and reduce task as well, so you can see how those are different behaviors. You're using 500 and using 500 there, what actually output show you. And just give it a try and see the comparisons. And if you have questions, you can ask me why there are differences there. Okay. So that's just a quick examples of Hadoop streamings. Those are the exercises specified in there, and we have example code in the folder as well. The example 4 should have gave you step-by-step instruction how you run them. It should work. If it's not, just let me know. On the exercise 5 is walk you through how you can use Mahout to do some basic programmings. So the Mahout is a machine learning library that's being implemented for Hadoop, so it has a lot of the data mining and machine learning algorithm being implemented in there. If you just type Mahout, it will show the list of the algorithm is currently implemented. Those are not being implemented by one person or one group, so they may have different signature, different standards. You have to read more about how each one being used and to be able to know how to use them and what format is going to take. Some of them is not that straightforward. They require some specific format of input, or they do something with some built-in parameter as well. So, but all the source code are available as well. So you can take a look, you can do modification, and it's best to be used as a Java library with your own applications. You can use it with another Java application you are writing, or you can use them within Python through the Hadoop streaming as well. The rest of them, the slides and also the exercise 5 is give you very detailed step-by-step what you can do to run the k-means clustering with routers newsgroup data. It's really not much to explain here, and the data you can downloading from the website I'm giving there. But I also already put the uncompressed file format inside /time/data as well as in the /training folder you are downloading. So you don't really need to downloading the data. You can starting with the step 1. One thing I want to mention is that here the step 1, the first line, is actually executed on your local machine and your local consoles, and the output is also on your local file systems. Then the second step is to put in that transform the format into the HDFS. And the rest of steps is actually working through the Hadoop clusters. So I'm showing this example just show like from beginning to the end how these things can be done. The routers newsgroup data has certain particular format, so that's why you need the first step to converting it and to be a file format that more easily to be used by the rest of the things. The other thing I want to emphasize is in this case, we actually extracting the text and into a sequence file format inside the Hadoop clusters. So you can store your text file inside HDFS. It's just going to be your regular text file, but it might be a little bit less efficient in terms of storage ATUs or with subsequent processings. The sequence file format is a kind of a format that used more commonly in the HDFS in the Hadoop applications. it written in a binary way, so it's more efficient. And each line is basically it just writing the key value pairs as a sequence format. So generally, it's just for purpose of the efficiency of the data processing. The first two steps is really just converting the files you're downloading from an arbitrary file format into that sequence format, store them inside the HDFS. Then it runs a normal k-mean clustering on documents, on set of documents. So step 3 is to generating the kind of the term frequency vectors. Once you execute this and you go to all those input and output will be stayed on your HDFS. So by default, it should be under your slash users slash your username, and then followed by those directory names. It will generating the term frequency vector matrix and the term inverse document frequency matrix, which is used for next step for k-means clustering and to getting the document clusters. So the step 4 is really the steps to run the actual clustering algorithms. Step 5 is a way you can dumping the result out from the Hadoop clusters and to your local file systems. You can do a check. If you're dumping them out, it looks like something like this. So each cluster is one group. It tells you what's the top terms in there and what's the statistic of the computation there. At least all the essential parameters in the command and as well as in the exercise.txt. So you should be able to follow them. If you need some explanation or there are some additional parameters, if it is something you really can use, because this is actually something you can really use if you're doing text mining jobs. You can specify different distance matrix you want to use. You can specify a slightly different algorithm you want to use. You can have more detailed control on how the algorithm works. Again, they say we just use them as examples how you can use Mahout and how you can run through the whole processing there. You can try it with smaller data set, and also you can try with a bigger data set and to experimenting more how different micro or reducer can affect. So it's good practice. And also, if you go to the /temp/data directory on the Hadoop file systems, I actually have the extracted data file in the same format is putting them there as well. So you could jumpstart from step 2, or if you want to skip that and directly just run the k-means, I have the TF-ID factors also put in HDFI, so you can jump to the step 4 and just try the k-means stuff. Okay. So other than those 5 things we introduced about HDFS and Yarn and Hadoop Streaming, Mahout, those are really just essential things that you need to get started with Hadoop. But Hadoop is really became a kind of environment and ecosystems. They refer to them as a group of the project which can help you to achieve a lot of other things. We can supporting them through the Wrangler as well. So if you have particular needs to run certain package or certain project, just let us know. We can walk you through, help you through setting up and how to run them. And the other things we support on top of Hadoop cluster is a Spark. Spark is not exactly like MapReduce implementation. It's better. It has some improvements. But we use the same kind of the cluster and the same resources manager for it and for you to run the Spark here. That's what we're going to introduce next. Okay. Well, so it's already 3:05. So, but I will still give you 5 minutes just to maybe stretch. Then we will continue at 3:10. And at the meantime, here is a recap on what's the reservation name, where the codes are, and how you start IDAP session, where you go for the WITS portals, and where is the exercise.txt. We have used them before, so everything should work. But if still mistake, just let me know. I will correct them. Okay.
Can we get these slides?
Yeah, simple. I think we already post the slides on the website, right?
Yeah,
So go to where you sign up.
detail of the class where you register under or portal.tac. The slides are there. So if you go to portal.tac, utexas.edu/training, and you go to the view details of the page, if you don't want to sign in, you don't have to. Just click on the blue link. If you click on the names of the slide, it'll require that you sign in.
Yeah, but we should already post them. There's a, what you see is the last one we had on the
Just go try. Just click on it. Yeah, no problem.
Is there anyone still have trouble to access or are you good?
Get 2 pages. There.
So if you go to the training page where you see the course information, you click details, and we have the files here. That's for the slides for the session. One is for Hadoop, and one is for the Spark you're going to see.
If you hit the blue link, you don't have to sign in. If you hit the name of the slide, you'll have to sign in to access it.
Okay.
It's just a little kink with the.
Is there any other questions or problems? So it's different because now with your compiling tool. So for example, the anti-aliasing, you can do the same implementation out. You can sometimes you can say model program to the anti-aliasing. The difference is really in the implementation of the program is basically for each of the users how to create and also the anti-aliasing implementation. So a lot of applications to using
Well, you can put it like
other things
or the I mean, we will be. Yeah.
Yeah, so that's what you should link. And the other link is just Q&A. It doesn't. Questions? There's no questions. Oh, you want to? Oh, you're going to present. Oh, you're going to present the Spark stuff. Yeah, well, I'll get you stuff.
But there's no task that can be done by just we definitely
So it's like dash mapper, file, dash file. That's it.
you can use it. It's really just
So when you're trying to accessing slides, make sure you're accessing the slides for these sessions. Now we have run a similar workshop before, so we have old slides. There are some old live there, but it's not exactly the same. So you can check the time. So if it's for today, then it's for today's class. Okay. I'm going to swap out, and so we can start with the Spark sessions. And again, at the end of today, we still have some time, so you can feel free to do some more exercise. Yeah, I don't need to do.
All right, so I'm going to drop him off the call, and then I want you to go ahead and join. So, Where is your?
The
Yeah,
accounts.
yeah, just hit.
This
There you go. Okay. Yeah,
one.
just
No,
go ahead.
no, this one.
Hit that.
No, that's the one. It doesn't work.
You
This
can
one.
just, yeah, you can just hang on. There we go. Now hit that. There we go. And entire screen. Share. And then go ahead and bring up your slides. There you go. Good deal. And then I will set you up to present. And you're good.
Okay.
You need to plug the HDMI cable in. So you can. Okay. Now just it's showing as a dual monitor.
Okay,
So
yeah.
let's go ahead and bring
It's working on it.
Yeah, so let's bring this up. There you go. And then maximize that. Oh, you can. There we go. There, perfect.
Okay, let's get started. So we just finished those on the Hadoop. So I'm talking about how to use Spark on Wrangler. So we support Hadoop and Spark both on Wrangler. And why we use Spark. So basically, the first one I will introduce why Spark is so popular recently. And then I would introduce some Spark components, talk about some Spark components and key concepts. And then the most important thing is the RDD, resilient distributed data set. So then we talk about how to create it and what kind of operation you can use on top of the RDD. That would and there's a key important operation is called RDD persistence or caching. So that would be making the computation faster. I'll talk about the workaround examples similar to the workaround examples which are just introduced in the Hadoop. And for the second half, then I would introduce how to launch the Spark on the YAM. The YAM is a resource manager, and then introduce something in the machine learning libraries within Spark framework. And if you're using Java, then you probably need to module load the Apache Mavens to compile, to build the Java source code. And we also build it into a module on Wrangler, so you can use the module load command to load the Mavens. At the end, then I would try k-means examples, and then there'll be some exercise, so you can practice. So we already introduced some histories of MapReduce and Spark. So basically, the Spark just invented like 2 years ago. So at that time, when in 2014, it's kind of like version 1.2 or 1.3. So the one programming language called R, which is not incorporated into the R distribution at that time. So right now, after maybe 1.4, 1.5, so the R already incorporated into the Apache Spark distribution. But on Wrangler, we didn't use the Apache distribution, we used the Cloudera. So the R programming language in Spark is not in the framework yet. So if you want to use R programming language, you can load a module called Big Data R. There will be then you can use R programming language to use in the Spark platform. We already talked about the concept of MapReduce. So I'll talk about some limitations of the MapReduce. When you look at those map functions and reduce functions, always you have to figure out what kind of command you should put in the map functions and what kind of commands you have to put in the reduce functions. So if you mess up with some output, then the reduce function cannot accept those key values from the map functions. So then your code will crash at the end. And it's very hard to debug using Hadoop, basic Hadoop framework, because it's not interactive. It's not like when you type Python, when you type 2 + 3, it'll give you 5, right? So it would be easy to debug using that kind of interactive shell. So in Spark, actually interactive shell for the scalar is a programming language. It's kind of like similar to Java, but it's on top of Java. They develop an interactive shell for the Spark. And also you can use Python. There is also an interactive shell provided in Spark called PySpark. When you type PySpark, you go into a interactive shell. You can type command line by line. So it's easy for you to debug your Spark code. And also within the Spark, you don't, actually the MapReduce function is not very obvious at the end. And when you see the word count examples, you will see there's no any like map functions and reduce function in the Spark framework. And also in the Hadoop distributions, lots of people's, because there's not very easy to debug and there's no interactive shell, and there's also different purpose if you analyze some data like Facebook status change. You have to use some some real-time data. So you have to use other tool on top of the Hadoop. So somebody will build some other tools on top of Hadoop. So you can see here there's a MapReduce framework and there's tons of other tools built on top of the Hadoop. So actually not very easy to make some efficient computations on top of these tons of tools built on top of the MapReduce framework. And that's why there's a necessities to build another one called Spark. And the Spark also very much faster than the Hadoop. When you can see here, why it's faster? Because it runs the computation in memory rather than the MapReduce on the disk. When you read the data from the disk, it's pretty slow. And in recent years, there's no any like progress in the disk read and write. So it's better to put all the computation in the memory rather than read and write from the data from the disk. As I talked about in last slides, and for the general purpose, Apache Spark has many libraries in the distribution, such as machine learning libraries and some SQL supporting Hive query language. So it's like called HQL. And for Spark, you can program in any language, like Python, Java, Scala, and also support SQL queries. And the built-in libraries, such as machine learning libraries, they're still improving it. So if you're using the machine learning libraries in Spark, there's one called ML-lib, which is the older version, is like expose the lower level of APIs. But right now they develop a new one within the ML, machine learning. This one will expose the API in higher levels. So usually you have to use those new one in the ML rather than the ML-libs. So for Spark right now, there are two types of people using it. One is data scientists. They usually use the Spark to analyze the data and model the data. For those developers, which know a lot more details, software engineer details, they'll use Spark to develop their own program to process real-time data, process some historical data. And if you want to remember what's the feature of Spark, these 4 points would be a good summary of the Spark features. First, the most important feature is interactive. So you can write your command line by line. And then all of those is lazy evaluated. You can use the collect command to collect those intermediate results from the memory.
So can you go back to the previous one? So can you say a little bit more about memory? So when the data size go beyond the memory size and the data has to be.
So actually, you can look at the distributed memory as a big memory. Like in this node, the memory in one node connect to another. You can look at when you load the data set, you can look at this distributed memory as a big memory chunk. So if you don't think about the detail of the network connections, like this kind of, so when you load a pretty big data set into Spark framework, use the text file command. So actually, you will split the file into separate partitions and send each partitions to every node. Then, for example, the node 1 will have the first 1,000 line, and the second node will get the second 1,000 line. So then you send the computation to each node, then we run the same scripts in each node to do the computation, like sum those values on each node together. And then the driver program would be collect those summations and then sum those summations from the intermediate summation results from each node to the drivers, and then you can get the total sum in the end. So that then you don't have any memory problem if you have a big data set you cannot load into your laptop. So for example.
So by using this memory, Spark assumes there's no need.
Yeah, there's no any need. So you automatically sending out those data to the memories and then automatically split out into different partitions.
So what's the memory, what's the network the Spark assumes? I think in the previous presentation, the assumption of the Hadoop is that the network connection is sort of slow, right?
Maybe Weijia can explain in detail.
So one of the fundamental difference between Hadoop and Spark is in the Hadoop we store the data in different data node and processing it locally. And in the Spark, use in the Spark clusters and the data is also partitioned and stored in the different nodes. And in this case, the data will be first kind of cached in the memory of that node rather than directly from the disk. In the Spark, you can read the data directly from the local file system. Then it's being distributed out into the worker nodes. It's the same process as you put your data from local file system into the HDFS, just instead of to the local disk, you are going to local memory system. But also, the Spark can read file directly from HDFS system. So if your data already in the HDFS, you will read the data from there to the memory for the processing. So eventually, if your data big enough, it won't be able to read all the partition inside the node into the node memory. So in that case, it does do some caching and it will reveal the data needed from the disk. So that's the reason why
having the disk is for a large
Right. So for the really large applications, right now it's the Hadoop is being used together with Spark because Spark is more like a memory processing, but it still need the HDFS as a sort of hard drive based data storage to back it up. So it's efficient. It's more efficient for your Spark application to read data directly from the HDFS for both efficiency and for the reliability of the data as well.
So also for the network latencies, some computation would need like sending the data from one node to another, but some computation just like summations. They don't need to send some computations from send some intermediate results from one node to another. So it depends on the computation itself. So there's several key components. The lower level is the resource managers, like cluster managers. There's a standalone schedulers, which is within the Apache Hadoop distribution. And the other is YAM, yet another resource negotiator, which we're using on Wrangler right now. And the other called Mesos. And on top of these clusters managers, there's a Spark core, which actually is introduced the resilience distributed data set, the RDD, and all those operations within this Spark core functions and operations. And on top of the Spark core, there's SQL structured data, which will handle the Hive query language. And the Spark Streaming is a real-time processing tools, which can use for like the status change in the Facebook web page. And also there's a machine learning libraries. And I haven't tried the graph processing yet because it's used for the network, something like a social network graph. So as I introduced in the figures here, so there's really several components. So it's the core actually handling the resource management and fault recoveries. When you write some functions in the RDD, if one node fail, then the RDD would be rerun again to retrieve the data from the disk and then generate the intermediate results in the memory. So there's a fault recovery. And the SQL, so it supports high query language and also supports some other structure data type like JSON and high tables and Parquet. And the Spark streaming should be similar to the Hadoop streaming process. And there's a machine learning library within the Spark distribution. And Spark also support the graph computations. And that's the core concept of the Spark. So there's a driver program, which would be initial Spark context. When you use the interactive shell, when you type the py Spark, actually automatically create a Spark context by the interactive shell. So you can just use the SC as the Spark context to load the data into the RDD. And between the driver program and the worker nodes, there's a resource managers here. So I take care of how to allocate those resources. And for each workers, you can specify the concept of the executor is equivalent to the containers in Hadoop platform. So you have to think about how many memories can be used in each node. For example, in Wrangler, the maximum memory for each container is 8 GB, and the total memory for each node is 128. So actually, you can launch 16 if your memory is up to the maximum size, like 8 GB. Then you only can launch 16 containers at the same time. So you can think about the main constraints for Spark. It comes from the memory instead of those how many processes you can run. So you have to think about memory first to see how many executors you can use in each node. And within the executor, you can parallel several tasks for the executors. And the RDD, it stands for Resilient Distributed Data Set, should be. And it's the primary abstractions in Spark. So it's similar to Hadoop, also the fault tolerance collection of elements that can operate in parallel. And it's immutable. That means you cannot change anything within the distributed collections, but you can transform step by step into the one you want to collect at the end. So as I talk about how those distributed data set created, it load the data into the each nodes, and then load the data into the RDD, and then split the data set into different partitions. In the Spark, you can define the minimum partitions in the RDD. When sometimes you run the Spark code and then there's one line saying errors, not efficient memories, so you probably have to increase the minimum partitions in the Spark. And when you create RDD, there are two types. One is to parallelize the collections. You just take existing collections and run functions onto it. And the other, you can load the external data set, like text file, JSON file, or other like structured data format. So that's the step to create a Spark context. So within Spark, there's several things you have to import. Most frequently, you have to import the Spark conf, which defines some variables like masters, what kind of master you have to use. If you want to run on the local mode, you just need to put local and then square bracket how many core you have to use. This like local 4, square bracket 4. So that will be run the Spark program locally. And if you have a batch script, so you can submit the Spark using the Spark submit and then define the master as the YAM client mode. So that's the one we support on Wrangler. So from this line, you can see here's create a new Spark conf. Right here, you can set the application name and then set the master to be what kind of mode you want to use. And local, either local or either YAM client. I will I'll talk about the difference between two distributed mode. One is called YAM client, the other is called YAM clusters. So I'll talk about it later. And after you create a new Spark conf, so you can initiate a Spark context using this new Java Spark context. So then you get the new Spark context as the variables SC. So using the SC can continue loading the data, such as sc.text file. Then you can load the text file from either HDFS or from local file system. So using the shell, you cannot use Java to interactive run the Spark, because Java, you have to build it, you have to compile it. But if you're familiar with Java, you probably can learn the scale up. And also, if you're familiar with Python, you can use the py-spark to run the Spark interactively. So there's one problem. If you have many dependencies, you want to import those libraries. For example, in my project, I have to use the bio-Python package. So if you want to use some functions within the bio-Python package, you have to zip the whole library into a .zip file or .egg file, and then use the command like --py-file in order to be able to import those functions in these libraries, because there's a dependency. You cannot point the path as a local file systems to the Spark, because it also every node need to know where those functions come from. So I have to actually to zip them into zip files, and then use the --py files to resolve these dependency issues. And then after you have the spec context, so you can load external files such as TXT file, JSON file. The default path here would be from the HDFS. If you want to load files from local file system, you have to start with the file and then slash, and then adding the path after the file. And then this is the second way to parallelize a collection. You can define an arrays list as 1, 2, 3, 4, 5, and then as an integer list, the data, and then you can parallelize this data, and then that means split this data set into several partitions and then send it to each individual node. So there's like, you can define all kinds of data internally. There's 3 important RDD operations. I should call maybe 2. The first one is transformation. That means you construct when you load the text file from the HDFS, you create a RDD. So if you want to count how many words in the RDD, you have to make another transformation. And these transformations are actually lazy evaluated. That means not computing their values during this transformation. And the other operation is called actions. When you use the actions, actually would be collecting data from those nodes to the driver program and then show up the results on the shell if you use the interactive shell. So there are several types of several functions of transformations I will introduce later. So this kind of transformations actually optimize the required calculations, and also can think of, it's very easy to recover from some failed nodes. You can think of the RDD as not as a data set, but a collection of commands, collection of functions within it, actually not computed. You just store these sequential functions within the RDD. When you use the actions functions, you will call the transformations back to the beginning. So when you want to tell whether the functions is a transformation or actions, you can use, in Python you can use the type. If you use the type and then put a variable's name within it, you will show the type of the variables, like it's a RDD pipeline or something like that. So if there's actions, there will be the type, the return type of the action would be different, would be some kinds of like list, set, or dictionary within the action return type. So action, there'll be the actual computation happens in Spark, such as a command like collect. When you collect the results from the memory, then you can show up all those results in the interactive shell, and also can save the results into the file system. The lazy evaluation, when you define those functions and run those functions, you not compute or store the data into the memory, such as the text file command. So it's just like a pointer, point to the file. It's not actually loading those data in the memory yet, unless after the transformation there's any lines of actions, functions happens. So these are examples. When you create a Spark context and use the text file to load the data.txt, so you actually create a pointer to this data rather than load the data into the data set, into the memory. And then you use the map functions to calculate the line length. And it's also, the map function also is lazy evaluate. It's just not doing the computation yet. So at the end, when you use the reduce function, this one will be action, will be return how many total lengths within the text files. And all of those Spark is not very strict map reduce function definitions, but they're still using key values concept. So in Java, if you want to create a key value pairs, you use the map to pairs function. And there's for example, you have to transform one pair of RDD, like a list of key values of 1, 2, 3. The first one will be the key, and the second one will be the value. And when you use the reduce by key functions, and here's past the summation functions in the reduce by key, the result will be, can you tell me the result will be the result from the reduce by key function? Passing the summation here, x plus y. And this is the key value list. So what's the result when you use the key value pairs here? So it's similar to Hadoop actually. So the result will be 1, 2, because there's the key 1 only appear once. And then you can see here's like 3, 3, the same key. If they have the same key, there will be sum these two values together, like 3 and then 10. So you return a two elements list, 1, 2, and 3, 10. And if you use the group by key function, not doing any functions, not doing any operations, you just return the 1 and 2 and the 3. There's a 3 key here, and then return 2 elements putting together within a tuple. And then the map values functions, you can something for this example, you can add 1 values for each key here, like it will return like 1, 3, and then 3, 5, 3, 7. So most of these group by or reduce, the reduce by key function is very useful in Spark. So you probably have to remember this one. And sometimes you have 2 RDDs. When you load 2 data sets into the RDD, you can do some operations with these 2 RDDs. So also is for all those transformations are lazy evaluated. You have to remember. So it did not do the computation. So it just transform the RDD into another one and then into another one, unless you do some actions. So when you use the join, there's a first RDD called RDD, and the variables for another name called other. So when you do the operation like join, you will see how many common keys here, like 3, there are 2, 3 here, and then they will put 4 and 9, and then 3, they're common keys here, 3, 3, and 3, and 6, and 9, put together into a tuple. So for the action, there's also The important one is collect function. You can collect everything, every RDDs from the memory. Also, you can use the count by key. The same examples here. When you use the count by key functions, it will show you the frequency of the key in the list. So you return 1, 1. Then there's a 2 elements here. So you return 3, 2. And then collect as a map. Pretty straightforward. And also you can use the lookup functions to look up the values of a specific key. Just like 3, when you look at 3, it will return the value 4, 4, and 6 from the RDD. So all these functions are actions. When you use these functions, if you use these functions in the interactive shell, you return this kind of a list of list. The most important features of Spark, you can pass functions like the functions in external libraries like Python, like other Python libraries, or you can define your own functions and then pass the function name to do the computation parallel. So for example, you define so this example is similar to the example here, like calculating the length of lines. So, but you can define your own functions like how to sum up those lengths of lines. So the first one would be get the length and then define functions here. There's a function, and then there's a summation function here. And then after you import the data and then do the transformation using a map, and then use the dot reduce. For here, you just pass the functions, get length, you define here. And then also you can pass the summation functions in the reduce methods here. Then you can compute the summations parallel. There's other important features called persistence. It's like caching. One example for this important feature is when you when you program in logistic regression and want to estimate the coefficients using the gradient descent. So at the beginning, it's by iterations, right, for the gradient descent. So each iteration, you have to use the design matrix, the X matrix, combining the Y together. So for each iteration, you have to use the design matrix. So you just can cache the design matrix in the memory, rather than each time when you finish your one iterations, you have to read the data from the disk and then to the memory. So after you're doing like 100 iterations, probably the Hadoop process will go crazy, like reading the data from the disk many times. So in this case, you can use the cache functions to cache the big data sets in the memory for another iteration. So you can directly do operations on the same data set many times. So it's very convenient and making the Spark operation faster than Hadoop. You can see if you use the data set many times and then put the data sets cache in the memory, then actually can get 10 times faster than Hadoop. So that's one benefit if you want to use the data set many times, use the intermediate results many times. Sometimes when you create a RDD and then transform the RDD into another one, the first one, second one, but you don't want the transformation to run many times. So at the intermediate result, you can cache the transformation in the memory, then don't need to go through the previous transformation many times. There's another way to save computation cost. And as I mentioned, you have to think about RDD as tons of previous constructions rather than a physical data set. So then you can easily think about the fault tolerance because every time when there's a fail in individual nodes, you can grab the transformation code and then rerun and then we get the data and then do the transformation and then prepare the data set for you. So, so remember, think of the RDD as instructions other than the physical data set. That would be easy for you to understand the Spark framework. So sometimes there's a need to broadcast the variables. So almost 4 o'clock. So when you create the purpose to broadcast the variable is to reduce some copying the big data set from one node to another. So the broadcast actually like a cache. So cache the big data sets in each individual executor, so you can do the computations locally. So you don't need to like every time when you copy the data from one node to another. So you just want the data fixed in each node. And there's another example, another features called accumulator. So when you look at the example here, use the Spark context and then parallelize. And then there's a list 1, 2, 3, 4. And then for each loop, there are 4 elements. You want to use the accumulative function. There's associated operations called accumulator.add. So you can add these 4 elements together without specifying key value pairs. So there's another features. But the important thing you have to remember that if you want to get the results, actually you cannot get the intermediate results for each individual task. You only can get the results from the driver program. So the driver program is the only one can read the accumulators values, not each individual task. So there's several supporting data formats, text file, JSON, CSV. The sequence file, just as Weijia introduced, is faster using this format. And the object file is a wrapper around the sequence file. It's pretty slow, but somebody asked why we want to use the object file, because object files you can set any object types in the object files. So that will bring some convenience features for the Spark operations. You can say like a list, like a map, or even the RDD in an object file. So as you know, there's what Weijia already introduced. There's a local facetance. That means those paths within your home directory will be a local facetant, and the other is the HDFS. You have to use the dash put to put the local file into the HDFS. That will make the Hadoop or Spark operation faster. And then also support database. Here's some examples you can run. So first you have to adapt to the reservation. And then right now you can do the example here. Just follow the directory CD to the work and then DMS Spark work count. Let's give it demo here. So you just can copy paste. When you look at the work count examples, this what's inside it. So the file to build the Java is called POM. POM stands for Project Object Model. So it's an XML file. Within it, there's some you look at the content of it, just like this. Specify some dependencies, what kind of versions and have to use. Then use the Spark submit command, you should be able to run it, but you have to change the directory into another one. I think I already changed the permission into read. You also can read. Well, haven't go to the compute node. So remember there's a logging node here, so you have to go to the compute node. Anybody try it? Can run? You get any results from the program? The what kind of example? So you can try the workaround examples right now. So it's like for now it's like a 10 minutes break. So you can try everything here. So you print out the results. After there's several log errors, that's because the cloudless 1.5 distribution has some issues. What's here? So the directory for the book, you can change the directory into the one who has the CD. Books.txt. If you want to use the local first, you need to put the file, and then Spark.
You can also use the same book.txt also in the /com/data in the HDFS. So you can just do /com/data and book.txt. It will by default it will use something from the HDFS first.
That's a problem with your try the one from
Oh, there's dot here.
yeah.
You just delete the
You can just try
delete the
from
dot here. Should work. That's your
from
HDFS.
version.
Yeah. And you can see the word count print out here. So this is word and counts. So the default will use the HDFS temp data. So if you want to load the data from the local file systems, here just there's a typo here, so you just delete this file and then use the local file system you just run. It should give you the correct result. So you can either use the data in the HDFS or local file system. So you can see those return the key-value pairs. Somebody want to? So my current directory is within the word Spark word count, and within this directory, we just use the compile jar file, and then put the location of the book.txt. You can either put your book.txt file from the HDFS or local file system. Either one will work. So you notice here the -- master. This one define the mode of the distribution. So if you use -- master and then local and then square bracket and then 4, that means run the Spark in your local node.
Can you do a which Java real quick? I want to make sure.
Which?
Show me which Java or your Java home that you have set.
Right now? Which job?
Java.
What's that?
JAVA Java.
JAVA. Oh, which Java? Okay. Somebody near
your Java home.
Somebody near a new version of Java?
Well, he's getting a Java unsupported class version here on Java word count. I'm just trying to make sure his Java home environment version.
There's a new Java, but you have to load the module. You just module load. Module load. Maybe Java, I think.
Java what? 64?
Let me check. We just should be Java 64, 1.8. You can try to load this one. Java 64 should be fine. What's the error? Didn't get it.
Okay, thank you.
Okay, they fix it?
Default is 1.7.
Okay. Let me check.
Get output at the top.
Oh, 不错啊，他们为什么要1.8的呀？
So your word count example, at the end it gives a lot of error message.
You just this because the newer Cloudera distribution. It's a log. It's a log error, so it doesn't matter. Like,
oh, I didn't set up.
yeah, the log is didn't set up correctly. So at the end, there's some error just because then we updated the Spark into a newer version 1.5. Previously, we used the 1.3. There's a crowded distribution errors here, so it doesn't matter as long as you can finish the results. You just ignore those errors at the end.
It doesn't find in this file. I'm sure it's in these locations. Let's go. What to say? The component errors.
What's the code?
No, it's kind of a
Jason.
Yeah.
Can you click on the link to the file that's on the factoring page? What's the, it says permission to manage your file.
Is he signed into the portal?
No, it's
Yeah.
just right now. It's
Sure.
just yeah. Go back to your previous.
Try the blue
previous-
button next to the actual file name.
Maybe it's on.
Go back to the previous page.
This is for the slides?
Yeah.
So I need to find them.
Yeah, try the.
First is why I asked for okay. So without how we're looking for the parts, it's actually a pass. Okay.
Were you able to get to it?
Yes.
So it's the same thing, same
that's
as.
that's a Cloudera error.
Cloudera.
Okay,
That's
so
a
there's
So
just say
You can't sign this.
I think the result still have problem to run Spark.
Mine's at the grid map, doesn't match, so.
let me ask that. I haven't actually read this. I'm pretty sure it's just gonna be solved.
Yeah,
Yeah, that's Cloudera distribution.
The grid map is trying to compilation sign
Where does this output, or does it? Is it just a standard
Well,
out?
if you just run the command, in the example here, it just turn off. Even if you save it now. So you see it. Another one.
Oh my God.
Yep, so I just know there are some errors you will see that are due to the Cloudera distributions, some configurations in there. But in the middle of those stand output, if you run it correctly, you should see the value pair. Now, you see this, this is, that's correct.
Yeah.
So this is I don't know.
Yeah, at the end you get some like handlers, context handlers, stop. This issue is just like Cloudera.
So the by default, the Spark looking for this pass is HDFS. Yes.
So if you finish the work example, we can continue. So that's the source code for the work example. So you can see create a new Spark context, and then that's the key value pair, worked and key. So all of you finished the work example?
Class does not exist.
Let's check how you can just try the data from which class. This is the such blank study data and such context. How do you do it?
Yes, you don't actually have.
Okay, that's my.
You have to copy that book. I didn't see anything.
Just continue.
就接着把这个讲完嘛，讲到4点半
对啊
差不多了。
差不多。
整个现在后面也没什么，就可以简单一点。
Yeah, just 10 minutes. So using the Spark submit, actually submit the Spark applications to the clusters. So the driver actually the masters. So it's the central coordinates control how to assign those, converting those users program into task, and using the directory cyclic graph tank. So it's just handling those sequential tasks, not independent tasks, but using the graph. So also you schedule the task on executors. So for each executor is like a slave, like a worker nodes. So the driver will collect those final results from each workers. So for the cluster managers, we right now using the YAM. So you can see we use the master --masters YAM client. So that's the distributed mode we use right now, and we also only support this one. So the difference between these two deploy modes, the symbol pretty simple. For the client mode, actually the driver running on the node you submit the program. So for the cluster mode, so the driver program would be running in the clusters. So every node can running inside the YAM containers, but you don't know which node you're actually running the driver. So for the interactive shell, that's the one example. So you have to get those inputs from the current node. So actually it's a YAM client mode for the interactive shell. So for the machine learning libraries, so you can try those examples. And for the Apache, Maven is a tool to build a Java using the project object model. So you want to build a Java code, you just use mvm package commands here. So if you want to load the module, just use the module role Apache Maven. You load the module in the current environment, setting up all those runtime environment for you. And the example for the machine learning libraries is the k-means examples. So if you want to see the source code, you just go into this website, and then if you want to run the machine learning libraries, so you just copy and paste. There are two ways to do it. The first way is running your Spark using the standalone cluster manager. The second way is use the distributed yum client mode. So either way, you can try it. So there's a big data set in the HDFS called k-mean data big. And that one probably have to finish it within like maybe 10 to 20 minutes. So you can try this small one first. And for other examples, the instructions, you can cut the instructions and follow those instructions in this text file to do the demos, word counts, and machine learning libraries. So you can try to run the k-means on my. So the first parameter to pass in is the input file, k-means data.txt. The second parameter is the how many clusters you want to define. You can define 3, you can define 4 clusters. So the output will give you the centroid of each clusters. So the data file is it's a three-dimension points. So I could run it. It's running. So going back to here, so you can see the cluster centers. So when you define 3, because the data set is in 3 dimensions, so here should be the first one should be x, y, z. So it's in 3 dimensions. So that's the 3 cluster centers output. So you can, if you cannot access the local file system, you can use the temp, the HDFS one, tmp data, and then k-means data, txt. The second one should be, you can define 10, maybe 4, 3. Maybe 4. So it's a very small data set, probably. So there are 4 cluster centers here. If you want to try other machine learning libraries, you can see those source code on the link. So that's the machine learning libraries source code. And then the k-mean should be called 2 k-means. So this one, Java k-means example. This one is the Java source code. And then if you want to test other examples here, and if you need some data set, you can go to the link here, data, and they'll provide some small data set for you to test for those machine learning libraries. The linear regression data, so one, and then support vector machine. So you also can try it. There's a data set for you to run. The result is print out on the console. So the results will be going up before some errors popping up. So it should be here, like cluster centers. So you can see what kind of examples in the machine learning libraries. So this example is within the Spark distribution. So only if you type this one, you view first input should be file, the second should be K, that means how many clusters you want to define. And directory. That's the jar, that's the example jar file. So if you use jar tf file, such file directory. You can see how many class. You see the class. The K means going to top. Today also like dense k-means, and then Java k-means, then streaming k-means examples. So I think that's all the basic and Spark concept and commands. So if you like to use R, so you can follow the Spark R examples, word counts, and housing values, and then logistic regressions within the folder. So you just follow the instructions within the folder. Go to the Spark R folder to view some. Another way to do. If you want to use R programming language, so you need to load the module, load the big data R module. I think that's all. So you can do those machine learning libraries practice using the example jar file or those class within the jar file. So the jar is within the USR, lib, Spark, libs. So there's Spark examples. So those example class should be within the jar file. Just define, get the correct Java class name. Should be fine.
So that's about the slides we have for today. So we have the room until 5 o'clock, so we'll be here. So you feel free to go back to try an exercise. If you still have the exercise text open, at the end of that, you will see there's some Spark instruction as well. So one thing we didn't cover in the slides here is how to run a Spark shell, because that requires knowledge about Scala. But if you already know Scala or want to give it a try, we actually have some example in the exercise 6 in that exercise .text as well. So you can follow that, and if you miss any of the Hadoop exercise, now you can go back and give it a try. That has not if there's any problems. We will have the reservation valid until tomorrow, so if you have something else, you need to go now. You can still try tonight or tomorrow, but after tomorrow, the reservation will be ended, so you cannot try it anymore.
I thought it was Sunday. You told me.
Sunday?
I think it's Sunday.
So you can try the Spark shell. There's a Python, Python code in the directory, and try copy and paste. So that's pretty.
So I would suggest you at least try like one from each exercise to make sure you can run them. So if you want to go back later on your own, you can do that. And if you have any problem, you can ask us now. There may be some settings, maybe something with the systems.
Great. I just wanted to know your impression on the next.